anyways, I went ahead and solved this without looking at the answer key. And so I looked at the answer key after, obviously. And so I think that my solution is a lot more user-friendly. So for that reason, I want to show my solution to this one here, number 7, and see if you folks think it's more user-friendly. So we start with the problem here. X cubed times e to the x squared, as we can see. And so what are we going to do then to solve that integral? So let's break down the thought process, because you're going to see in just a few lines of some basic algebra, I get it to a state we want it to be in to solve it. So how's the thought process work? How does that happen? Okay, well, where it's going to start for me, I'm going to be looking at this and saying, yeah, I do want to do a u substitution. Okay, I do want to do u substitution. And what's really our only candidate for the inner function is x squared. Because remember, the u substitution is going to come down to the following identity, really, right? The integral of f of g of x times g prime of x dx. What does that equal? Well, that just simply equals the integral of the function of u with respect to u. Okay, so I'm always going back to that identity, always going back to that. I want that set up, no matter what. I want that set up. So the key thing here is there's going to be that inner function multiplied by the derivative. Well, our only real candidate for the inner function is x squared. So let's work with that. Okay, I've shaded under that green line. What do we have to work with that we could possibly transform into the derivative? Is x cubed. But we've got a problem, because you know that is, how is that going to be 2x? That looks nothing like 2x. What are we going to do to make that into 2 times x? I have no idea, but well, okay, I did come up with an idea, because there is something that we can do. Do you know what we do? What we do is we break it down like this, as we have on that next green line. Okay, instead of x cubed, x times x squared. And just arbitrarily, I add these parentheses. Okay, arbitrarily, I just end up adding these parentheses right here and here. Okay, so that's our outer function. What's our outer function? X times e to the x. Okay, and we're feeding x squared to that outer function. Now, here's the other key insight here that's going to save the day again and again and again when it comes to these integrals and u substitution. Okay, our outer function has more than one entry point for the variable. Okay, there's more than one entry point where we plug in the variable or plug in the function, in this case, x squared, right? It's far too easy to think about a function as having the one entry point. We plug in the variable, we plug in the inner function. No, right? An outer function may have many different entry points where we plug in that inner function. So in this case, we can think of x times e to the x, right? That's our outer function. We're plugging in x squared into that one. So we plug in, and well, we're still not multiplying by the derivative of x squared on the outside, but that's okay, because we can manipulate things in such a way that we most certainly are. Okay, we added 2 to that x. We added 2. Now we're multiplying by 2x. I'm multiplying by 2. So I multiply it by 2, and obviously we have to maintain equivalence. We have this 1/2 out here to maintain equivalence. So that's within 3 lines of some relatively straightforward algebra. We get set up for our u substitution. Now we're set up. The derivative is gone, okay, and we're just saying u times e to the u, and the 1/2 stays outside of the integral. And now what are we dealing with here? A stock integral. Okay, this integral is just cookie cutter, it's stock. And unlike Lars Ulrich, I'm not the least bit upset about the fact that this is stock. I'm happy because now it's going to be real easy to deal with, real easy to solve. So I'm happy we just got a stock integral to work with now. So, you know, the key thing is an integral like this is something you're going to want to memorize, right? X times e to the x. Yeah, that's something you guys are going to want to memorize because that is your use case. That is your quintessential, simple, introductory use case for integration by parts, right? So if we're doing that now, we just go into integration by parts. So this whole process, you know, you guys should know, and this is one you guys can memorize. Just one of those ones like, yeah, what's the integral of 1 over x? Yeah, right, that kind of thing. And so, you know, we go through that problem solving process using integration by parts. And what do we end up with? Yeah, x squared times e to the x squared minus ex squared, right? We solve it, right, in terms of u, where times 1/2, it's over 2. And then we plug the x squared back in and kind of go for a simplification. There you have it. There's our integral. So to break that all down again, right? The very, very hard part ostensibly was getting set up for the u substitution. Then once we're in that world, u times e to the u power, yeah, that's just a stock integral you guys are going to want to have memorized, right? And then go from there pretty well. That's your, you know, your introduction to integration by parts right there. But for this one, I hope just those few lines of algebra just kind of show my thinking, my thought process, and how I want to get it set up, right? You know, we want to be on the lookout for how can we create this setup where we're feeding the inner function to our outer function. We've got the derivative outside. You know, one thing we can do is we can realize, you know, when we're multiplying things like this, we can rearrange things in so many different ways, right? You see, I've rearranged things. I've arbitrarily added those parentheses. We've pulled an x outside of those parentheses. It can come in. Multiplication allows for a beautiful rearranging of the factors. And just like that, we get set up for the u substitution.